We exist so that organizations can maximize the value of their data. And so, yes, a lot of that data is in scary geospatial things, but a whole bunch more is in Excel spreadsheets and CSV files and Oracle databases and Salesforce accounts.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest today is Dale Lutz, and he is the co-founder of a company called Safe Software. They make a product called FME Workstation. You might have heard of this. I have used it before, and I'm a big fan. So Dale's going to talk a little bit about their work there at Safe Software, and he's going to talk a lot about the past, present, and future of geospatial and geospatial data. Dale is definitely a thought leader when it comes to these kind of things. He's a really interesting character, and I am sure that you're going to enjoy the conversation. But before we dive into the interview, I would be remiss if I didn't thank our sponsor, Hive Mapper. That's Hive as in Beehive Mapper. And this is the platform that lets you upload video data to the cloud and have it automatically converted into usable 3D geospatial data. Okay, let's get into the interview. Hi, Dale. Welcome to the podcast. Thanks so much for taking the time to do this interview with me. I appreciate that you're a busy person, and I'm just really grateful that we could find a time that suits both of us. So you are the founder of a company called Safe. Safe makes this amazing product called FME Platform, the feature manipulation engine. There's a whole bunch of geospatial in there, but before we dive into all that, perhaps you could tell us about this, how you started out. Like, what did this platform look like at the start? How did you get involved in geospatial?
Well, thanks very much, Daniel, for having me on your podcast. It's quite an honor. So yeah, my name is Dale Lutz. I'm the co-founder of Safe Software. Don Murray is the other founder. We were two friends that had met at a previous employer way back in 1990-ish. And in 1993, we decided to start a company that would move spatial information from where it was to where it needed to be used, recognizing that that's a hard problem and that some manipulation along the way has to happen. And so actually the name SAFE comes because of a play on a government program here in British Columbia, Canada, where we're from. Back then, there was a data format called Spatial Archive and Interchange Format, or SAIF, pronounced SAFE. We thought we'd be clever and name the company to rhyme with that and then try to win contracts related to that. SAIF, or SAFE, was made to facilitate the exchange of information between forest companies and the BC government so they could manage where things are being cut down and where things are not being cut down and just keep track of the inventory of timber in the province. But ultimately, there were different GIS products being used at forest companies and different ones being used at the BC government, and they wanted a neutral way to exchange information. We built software to help with that, recognizing that every situation was different, so it had to be adaptable. And then with time, that revolved into something we call feature manipulation engine, or FME, where SAIF was no longer the middle ground, where you could instead go right from one GIS software or CAD software to another and not make a stop in SAIF. And so that was how FME was born. And then from there, it got a fancy graphical interface. It received an ability to run automatically in the background in response to different events happening. That's FME server, eventually being hosted on the cloud and getting some visualization capabilities for data inspection. And fast forward 26 years, on Friday this week, December the 13th, is in fact our 26th birthday. So yeah, I was only 2 years old when it started, so I'm feeling great.
Well, congratulations. You've clearly had a lot of success with this platform. I have used it myself. Yeah, I'm deeply impressed. I mean, the amount of options and opportunities there are there to manipulate all kinds of different data and produce all kinds of results. It's really, really incredible. But I just want to take a step back before we really dive into what Safe can, or FME, the FME platform can do today and where it's perhaps going in the future, just to talk about that middle ground. So at the start, the thinking was around geospatial data, that we would transform it from one format to the sort of middle format to another format, and then that went away. What was the technology that made this possible, where we could go directly from one format to another without this middle stop?
Right. So the SAIF, or SAFE format, was this really clever, powerful model for storing spatial information. And the idea was that they wanted to create one format to rule them all. And there were very smart people that put a lot of effort into this. And their efforts actually are in use even today, although most people don't know it, because arguably SAIF is the grandfather of GML, which is widely used in lots of different government situations. But we were fortunate to be involved at the very beginning, and we had to design software flexible enough that it could handle this amazing, again, one format that would try to rule them all. And so our mental model, our programming model inside of what became FME was this really, really flexible thing. And so at the beginning, we were building these executables that would go from CAD, say MicroStation, to SAFE, and then another one that would go from SAFE to shapefiles. And Don had designed a common approach to making these translators. We had the same sort of layout, the same class libraries being used that we'd invented. And I was actually tired of building all of them, because I think at one point there was about 8 of these that would go one, A to B, B to A, and then all the way around. I had to deliver these all to the customers. And like any good invention, it was born out of laziness. I decided one weekend, all these are very similar. I can somehow squeeze them into one program, and then I only have to build one thing. And when this program starts up, it'll read a little file that'll tell it, hey, today you're going from MicroStation to SAFE, and then tomorrow you'll go from SAFE to Shape, and that'll just configure it, and it'll just do its thing. And so I spent a weekend. Don had built a beautiful design, and it all just worked. And when the weekend was over, I realized, hey, I don't actually have to stop at SAFE. I can go right from MicroStation to Shape and never have to stop there. And so SAFE moved from being in the middle of a hub between different formats to being just one format like any other. And FME became this thing that was in the middle of the hub. And from there, we went from having, let's say, I think 8 formats very quickly to 17, and then today now more than 450. But that was really how that happened. And over the years, we've seen multiple times the concept of one format to rule them all right over the hill. And almost always those, for whatever reason, have some flaw or another why they don't really rule them all. They serve a purpose, and they are good for a purpose, but ultimately, it's just sort of like some fundamental law of the universe. There is no way to have one format to rule them all. There'll always be more formats being created. And we couldn't have imagined that when we started, but we're just thankful that we're able to be there to help people as they adopt and move between these different developments.
I can completely understand why people keep returning to this idea of the one format to rule them all. It's a really attractive thought that we could solve all of our problems just with this one format. But at the same time, I have to admit, when I stop and think about it, it feels a little bit naive to think that one format can really perform all these very different specialized tasks we see a lot of the different file formats performing out there today. Yeah. You mentioned before, I didn't quite catch it, the number of formats that you support today. How many was it?
Well, we kind of have lost track, but it's at least 450. So it seems like we should be able to know how many there are, but we have extendable architecture, and third parties around the world have added niche formats in different industries and different regions. So we've lost track, but there's at least 450, and it's a little bit blurry. And I think we're going to talk more about this later, because what actually is a format? That's sort of a meta thing to discuss. But in the old days, a format was a collection of bytes in a file that you'd be able to put on a diskette and send to your friend. Today, a format might be data hiding behind an API. And if we start to talk about data hiding behind an API that we can get access to using REST calls or SOAP calls, now all of a sudden the number of formats in quotes that FME supports is actually even more than that, because what do I do about Salesforce or about Autodesk with some of their developments in Quantum, or ArcGIS Online or ArcGIS Portal? These are all formats, but they don't really exist on a file on a diskette that I can email to you or hand to you to use.
Yeah, and I think one of the interesting things you said there was, yes, they're all data formats, and there's lots of different kinds of data formats and lots of different kinds of ways of getting a hold of this data. But something that really stood out for me there is something like Salesforce. This is not a traditional geospatial platform, but yet they're consuming geospatial data. Location is also important there. So you're not. It sounds like you've moved away from these sort of traditional geospatial worlds with the CAD world, ArcGIS, QGIS, things like that. And now you're transforming and solving these feature translation problems between many different software platforms. Is that correct?
Well, I wouldn't use the language that we're moving away, but we certainly, so our hearts and minds, I guess our soul is always looking at the world in through a spatial lens, but it's kind of funny at SAFE. And if I'm really transparent, we've often gone for solving the hard problem and left the easier problem behind because for whatever reason, we aren't as interested in it. And that probably hasn't been the best business plan. I mean, we've done well in any case, but I think ironically, there's a lot more money in the simple things. And so I'll give an example. For the longest time, we never actually read comma-separated value files. So we read scary CAD formats and did really tough coordinate transformations between datums around the world and all this stuff. But if you actually had a comma-separated value, like A, comma, B, comma, C, whoops, we couldn't read that. And yet a lot of the world's data that needs to be integrated spend some of its time in a comma-separated value file. And so with time, we've learned that is actually where we can really add value to organizations. Because why do we exist? We exist so that organizations can maximize the value of their data. And so, yes, a lot of that data is in scary geospatial things, but a whole bunch more is in Excel spreadsheets and CSV files and Oracle databases and Salesforce accounts. And so with time, we've started to embrace more and more of those things. And our core customer base has realized, wow, this FME thing, not only can it make polygons and clean up my CAD file on the way to GIS, but wow, it can also transform an Excel spreadsheet to the point where today Excel battles it out to be number 2 in terms of our most used formats. We like to tell the story of one of our British partners was saying that they go to a municipality or a local community and do a demonstration showing FME, reading some CAD data, integrating it with some parcel data, creating a wonderful 3D visualization in virtual reality, and everybody sits around a table going, okay, yeah, whatever. And then they do another demo where they read a spreadsheet and write another spreadsheet where they just separate the data into 5 tabs. And the customers goes, what, you can read spreadsheets and do that? Like they're so excited. And so, the first part is the result of 26 years of R&D. The second part, not as much, but that's where the value is. And so we recognize that if we want to allow organizations to make great decisions as quickly as possible, that working with that other business data and being able to integrate it and sling it around and win with that is a big deal. There was just a quote from somebody on Twitter talking about, I don't remember, I think we posted a blog about 5 things that municipalities do to be more productive. And this person chimed in and said, since I discovered FME a year ago, I've quit using Excel and SQL to manipulate data and used FME instead and saved over 500 hours. And so there's nothing spatial about what his quote was at all. He was doing stuff in Excel and SQL and instead using FME. And so that's what excites us about our future, actually.
Yeah, and I think that really speaks to the fact that the data is where it is and people use what they have, right? If they're used to using Excel, then that's what they're going to use to manipulate data because that's the tool, that's the best tool they have. It's like when photographers talk about what's the best camera, it's the one that you have in your pocket or the one that you have with you right now. That's the best camera. Yeah. And I think that's kind of at the heart of what you're talking about there. And I think too, it also speaks a little bit to that really broad range we see in people dealing with spatial data, right down to the how do I manipulate my CSV file to how do I manipulate real-time satellite imagery and create these huge 3D geospatial worlds. So there's a huge spread here.
And I think it's been so wonderful, honestly, for us as a group of people here that just love solving interesting problems. It's been a spectacular industry to be in because the problems are always so interesting.
Yeah, absolutely. And there's always so many amazing use cases and they're constantly evolving. That's the thing that amazes me. This is definitely not an industry that's stagnating. It's almost running too fast. We're almost getting way ahead of ourselves in some ways. So we've talked a little bit about some of the problems you're solving and how you got into this space. But I'd like to just go back to these file formats just for a second. With so many different file formats out there, how do you decide which ones to integrate into your system?
Well, for the longest time, it's sort of like Mount Everest. If it's, why climb it? Because it's there. And so we would look and listened to customers. Overwhelmingly, our insights have come from our customers. And so over the years, as they contact us, I remember when we suddenly had a rush of people at an Esri user conference all coming to us saying that they needed help moving point clouds around. Like something must have happened in the industry where the collection of LiDAR and point cloud data became cheap enough for municipalities to start doing it. And now they needed it moved. And so whoosh, we would then say, there's a business need there. We'll deal with it. We'll provide ways of accessing it. So over the years, it's been customer driven. We look and see where the industry is going. We look at things like our friends and the various vendors tracking their developments. When Esri comes along with the new utilities network, we were involved very early because we could tell that was going to be a big deal and there was going to be a big need to migrate data into that. And so those kind of things drive us. We try to go like Wayne Gretzky, where the puck is going to be, not where it is. And so sometimes we're a little bit ahead. We started working on 3D things in 2007, and only, I would say, in the last couple of years has that really started to get traction. But you know what? You needed to be working on that for 12 years to have a good solution. So we try to go where we think the industry is headed. We look hard, we place a lot of bets, and we lose a fair number. So, there's things we built that nobody ever uses, and we are sort of sad about that, and we move on. We've supported some things. Actually, Google Fusion Tables just got decommissioned a week ago. So we put a lot of effort into that in its day. And I guess sometimes we can reuse that when it's time to migrate out and people use our stuff to go the other direction. But that's kind of guiding it. So we talk to our customers. We do this thing called FME World Tour. And my marketing team would know for sure, but I think we spend a day with about 5,000 users worldwide. I think that was the overall attendance across all 75-ish events. And so we're out there talking and listening to our partners, listening to our customers. We do that every spring. And then a lot of intel comes back from that. And that really helps guide us as well. And while we're kind of on that, what we've really noticed is that our customers are saying that the traditional business parts of their organizations also have been wanting to integrate spatial into their workflows. So the Salesforce person wants to know where things are. And so that is part of also what's driven us down the path of incorporating, I would say, more traditional data as well as the GIS data.
So as someone who spends a long time, or I should say a lot of time, sort of looking at the industry and trying to understand where it's going, and with your focus being on file formats and translation between these different formats, is there any sort of trends you see out there at the industry at the moment? Can you sort of identify any sort of roads we're going down in terms of file formats or maybe ways of exchanging data with each other?
We have not hit a plateau in terms of innovation. So there still are formats being created and being developed for particular purpose. Like I'm aware right now of, for example, City GML is a way of storing 3D data and a data model that goes with that. Well, there's a City JSON now, which is the same data model as City GML, but implemented using JSON. But that actually is a trend, storing more information using the JavaScript object syntax called JSON. And so we're seeing more things in that. A lot of data that's hiding behind REST APIs, you'll be able to get that out in GeoJSON. That's definitely a trend, or various flavors of GeoJSON. On the indoor mapping side, there's been a lot of development of things between indoor GML. Apple has been pushing IMDF, indoor mapping data format. And I think that was even recently submitted as an OGC standard. I saw in a report that's in that process as well. That is actually a schema on top of JSON and GeoJSON, but a lot of detail in there to help with indoor mapping. And that actually is a trend. We've mapped the outside world pretty well, but the built world, the inside world, there's a lot more to be mapped inside of that, and a lot more demand as we want to move the blue dot of our mobile devices into the inside. And so that is an area where we're seeing lots of interest. And guess what? A lot of those floor plans are done in old, nasty, ill-behaved CAD files. And so we can add value there to try to bring order to chaos. We also, a lot of those modern floor plans are in wonderfully detailed Revit files, which are 3D and in and of themselves not easily suited for indoor mapping. But again, we can try to bring value there. So these are some of the regions. I'd also say, just in general, data being in the cloud, and that has implications for raster as well. So something called cloud optimized geotiff. The open source guys in general, well, I'm using guys generically, women and men in the open source field are amazing in their speed of innovation. And so there's lots of things to track there. And cloud optimized geotiff is a way of having images that live and reside up in the cloud and cloud storage, things like Amazon S3, and are structured in a way that you can efficiently get at parts of them. Or you only want some of the data, you can get it without hauling the whole geotiff down. And so that's another area. There's these things called geobuffs and protobuffs, which are optimized for being very fast at the loss of readability and flexibility. And so those are other trends. So it's hard to keep track of all these things. Oh, Mapbox vector tiles, another modern thing to kind of cram data in a very compact way back in tiles, which incidentally, I'm old enough to remember when tiles were how we used to have to do things, and they were considered bad. And so then we went from having data in tiles to putting it all into seamless databases. And guess what? We're back doing tiles again. So all that's old is new.
Yeah. So I'm going to ask a perhaps very naive question here, but it's around what we talked about before with indoor mapping. What makes a really good indoor mapping file format? In my naive little mind, I'm thinking, well, why can't we just use the same file formats we have today? What's different about indoor mapping, do you think?
Well, that's actually the answer I'm going to give is kind of at the root of why are there so many file formats in general. But specifically, indoor mapping has a set of requirements that don't exist in outdoor mapping in the same way. So in indoor mapping, you have to take notice of accessibility issues. So if I have a mobility problem of some kind, well, which way is my path out? What kind of routing constraints are there, and how do we express those in a file format? So the data model you have to have is very, very comprehensive to answer some of these different questions that if you were doing census mapping, for example, you wouldn't care about. And so things like, what is the connectivity between floors? So how do you take a 3D problem and express it in a 2D map? Usually in traditional GIS, we aren't really thinking about stuff that's separated in elevation, that's stacked on top of each other. Normally in GIS, it's 2.5D. So yeah, we haul along the Z or the Z value for just because we're friendly, but we don't really make use of it. But in indoor mapping, the floor you're on and how you flip between different floors, super critical. And so that is some of the concern, and kind of, where do people want to go and what are evacuation routes? All these kinds of things need to be expressed. The connectivity between spaces, that is what gets the complexity of an indoor mapping file so much higher, because ultimately the tools that are going to use this make use of that in real time as people are making decisions where they are and where they want to go.
Earlier on in this conversation, we talked a little bit about an API, and perhaps we should be starting to think about that as a data format. And I can see there's a lot of buzz in the industry right now about 5G, and we're constantly talking about the Internet of Things. And yeah. I also noticed before when we talked about these different file formats that are coming out, a lot of the ones that you named seem to be something related to the way we transfer data on the web.
Yes.
What do you think is driving this? It feels like we're heading in that direction of real-time data, on-demand data, and we want it transferred via the web.
Overwhelmingly, that is the direction. If you go back in time, I used to say there's no reason for us to make our Workbench product, which is a graphical environment for configuring translation. There's no reason for that to ever be web-based, because after all your data is on a desktop. That was kind of my Bill Gates 640K ought to be enough for everybody phase. I began to realize, or we did at SAFE several years ago, that data is no longer on someone's computer exclusively. Lots of it still is, and that isn't going away. Lots of it still is even in the LAN, the local area network of an organization, but an increasing proportion and an important volume of it is never going to be local. It's going to be out there behind services, out there on the web. And again, I remember early on the guy who was actually one of the original visionaries behind SAIF, Ron Lake, recently passed away, a great loss to our community. Ron Lake went on to be an architect, the main architect behind GML. And I remember some presentations of his in the late 90s when he would talk about the internet dial tone. I had troubles. I mean, for me, the true dial tone of the internet was still a fresh memory. You know, the that you'd hear from dialing up. The young folks wouldn't even know what I'm referring to, but I'm sure you can find a YouTube video of somebody using a modem. But the fact that you'd always have the internet accessible to you at all times was a revolutionary, mind-blowing concept. And we've got there just about. Although LTE is pretty good for speed, but still for large data volumes, not so much. But 5G is going to absolutely blow this open. And so that vision of Ron Lake's from the late 90s of the internet dial tone and the implications of that for geospatial are going to be thrust upon us very, very quickly here. And even we're involved in an open source project right now to, this is pretty geeky stuff, but to hide grid shift files behind web interfaces. What this is about is that every country in the world is on the move. They all are moving a little bit. And so if you want to know where something is or where a measurement of location is, you really need to know what time that measurement was taken. And then you need files that tell you, if I wanted to know where that was 5 years ago, then you can do the shift. And there is no algorithm for that. It's just raw data. So you got an earthquake comes to Japan and boom, stuff moves by a meter here or there. So you have to keep track of this. Well, there's a lot of these files around, and the open source folks have managed to say, we've got a place we can host this stuff on the web. We've got an advent calendar of countries we're trying to get to submit their grid shift files. And now those files will no longer be on people's computers. We will just access them when we need them. They'll be stored online. And that's the move. You know, that's a very fundamental piece of the geospatial infrastructure. And we're shifting that from being downloaded to being just accessed on demand. And so that is the trend happening all over in every way. So ArcGIS Online is there. If you go to an Autodesk University conference, they'll talk all about Forge and their Project Quantum and the idea of storing design data behind APIs instead of in files. This is a tsunami that's washing forward, and I think we're going to be shocked at how fast it's going to hit us all. And 5G is going to just accelerate that. I remember thinking in about 2015, and I'm not sure if I was getting older. I was close to 50 years old then, so maybe the world was starting to, its change was outpacing my capacity. But I remember thinking around then that, wow, has the pace of change ever picked up? And ever since then, every year, it's been greater and greater and greater. And it's because of the combination effect of all these exponential developments.
So I can imagine, for example, when more of this data, like you were saying, is going to move online, it's going to be accessible via APIs, and we're going to have easier and faster access to it. My only question is then, what are we going to do with it? Like, we're going to use it more in different ways, I would imagine. But do you have any thoughts around that? Can you see any really, really big opportunities here in perhaps the way we use this data?
So we are, and I'm going to kind of crystal ball here a little bit, but we are surpassing the ability for humans themselves to get value out of this data. We're just overrun by it. We're just drowning in it. And so we're going to need fantastic tools. We're going to need machine learning and AI and these types of things to wring the insights out for us. We're going to need the ability to extract only what we need and care about and get that in a timely way. And we really hope that we can be part of that solution, but there's going to be many, many other companies and tools and so on that continue to add that. But I was recently fortunate enough to attend the Planet user conference. And there, the Planet, of course, is now imaging the entire Earth every day. And so that was kind of their mission one. And so they woke up one morning and said, wow, we're actually doing this. Every day there's a complete and total picture of the whole Earth. Now what? And so they are quickly creating services where you won't subscribe to pixels, you subscribe to insights. You say, I want to know when the crop situation, the crop health in this area has changed. And every day the machine grinds away, and once a week or once every month when something interesting happens, you'll get notified and say, whoa, the corn yield appears to be dropping or increasing, and you can adjust your futures contracts accordingly. Or If you're a municipality, I want to know when roads are built. I want to know when buildings get built. And you kind of pay the fee, and then you get a ring from Planet when there seems to be a new house being built, and you can check your assessment database and see what to do. So it's going to rely on machines to wring the value out, and then various automations to transport those insights to where it can be actioned by humans. And that's very much what's going to happen with our industry.
Well, just following along from that, where do you think the role will be then for the GIS specialist sitting out in organization today? How do you think their role is going to shift with this huge shift that we're expecting to see in the industry?
I think that there's two places. I think that they will be a key player in terms of providing some of the raw materials that the machine learning and the AI and so on will make use of as part of the process. So they're going to be feeding the machine with their specialized knowledge and their specialized data that can add value. So even in our own experimentation here, one of our staff, Dimitri, has found that when you combine imagery with a little knowledge of what's going on, some vector data, you can get big improvements in the outcomes for things you're trying to do with machine learning or AI. So that's one side of it. I think the other side is that those GIS jockeys out there that know what they're doing with spatial are going to be very well positioned to help really format and create the reports and the insights and the ways of expressing to the masses the results of the machine learning. So if the machine says, here's a new road here, the GIS person will be creating the system that takes that and combines it with the base maps they've got and produces the web page or the PDF. Ironically, PDF is where data goes to die, and it is a very common endpoint. Or it's the interactive chart using tools like ArcGIS or Esri Insights or Tableau. That's where the magic of knowing your way around spatial combined with these amazing visualization tools will provide the value for the last step where the human gets to see the results.
So it sounds to me like that we're predicting here that a geospatial specialist today is going to have to move more into that role of a communicator than perhaps a technical operator. Like I'm not suggesting in any way, shape, or form that we're going to anytime soon lose that sort of need to perform technical operations. But I'm a bit like you. I can imagine a shift over towards that communicating to the masses, like looking into the machine, understanding the process that has taken place, and taking the results and communicating them out to people.
And in a way that for at least many GIS people, that's just a progression, because many of my colleagues and customers are trained in some way in cartography. And all we're talking about is kind of cartography is about expressing in clear ways where things are on the earth. And this is just a modern cartography, if you like, where we're going to be expressing the insights of what's happening in our environment using a much richer, sorry people that like paper maps, but a much richer canvas than just paper maps.
Dale, I'm a little bit conscious of the time here, but I've got two final questions before I let you go. And the first one is, I think we've talked a little bit about the future and what we can expect to see, but what's the thing that you're most excited about when you think about the future of geospatial?
We didn't talk much today yet about it, but I think the application of virtual reality and immersive environments to help us understand where we're going and how that combines with the indoor mapping and understanding the worlds that we're building, that to me is an extremely exciting area. The whole idea, Autodesk used to say, experience it before it's real. And if we can experience changes in our world, if we can experience what a subdivision is going to look like, if we can experience the inside of a building before it's there, if we can experience the impact of a infrastructure project like a pipeline or sewer line, and let a large group of our stakeholders out in the community and decision makers know that in the most rich way we have as humans of communicating, and that's through seeing it and being immersed in it, whether that's gaming engines or upcoming VR, AR goggles from the Facebooks and the Apples of the world. That to me is just super duper exciting.
So I'd like to end on this equally deep question, and that is, what is the future of the shapefile?
Well, after the nuclear holocaust, there'll be two things left: cockroaches and shapefiles. That's how we often say it. there was it was actually just Shapefile Day on December the 12th, self-proclaimed by the Twitter parody account Shapefile, which is honestly the main reason for staying on Twitter these days, is to follow that account. She or he does an amazing job mocking everybody and kind of pointing out that Shapefile is not going to go anywhere. There was kind of a discussion in the last on Shapefile Day about how did Shapefile become the way it was, and it was documented and it was operational at a very early stage. So back in the early 90s, there was actually a contest on Twitter who can find the oldest shapefile on their directory. I weighed in with some from 96, but somebody else had some from 95. So I was beaten. But the fact that it was documented early, so there's sort of first mover advantage. If it comes out and it's explained. Now, other file formats were documented in the early 90s, but they weren't operational, and that there was no tools that could work with them. So this was documented, and there were free viewers. Esri was using it. You could edit this thing, and it just worked, and the barrier to entry was low, and whoosh, there it is. And now, in FME, you've got 450 formats to choose from, and yet number one format people choose is shapefiles because they're very sure that when they send it to their friend, they'll be able to use it. I've just heard, however, about a major airport that's planning to do a big project that involves multiple stakeholders, and they're going to use shapefiles as their interchange format. And I don't think that as a professional that brings me joy to hear that, but I can understand why that choice might be made, just because they're certain that all tools will work with it. However, you do pay a price, but sometimes that price is one that people will pay. And as the shapefile person says, is that field names are not for storing data. If you have 10 characters, that's enough to name your field. You shouldn't be storing more information than 10 characters in the name of your field.
Dale, I really want to thank you again for taking the time to do this interview with me. I have truly enjoyed the conversation. You're clearly a thought leader in this space, and yeah, I really appreciate you taking the time. We were talking before we started the interview here, and I mentioned that I bumped into your YouTube channel the other day, the FME Safe YouTube channel. I'd really encourage people to go along and check it out. You've got so much great information there. But where else can people go to either reach out to you or to learn more about what you're doing at Safe and FME?
Well, thanks so much for having me on. It was a lot of fun. It's always nice to stop and kind of zoom up to a higher level than the normal bits and bytes where I tend to live. But in general, take a look at us on YouTube. But we have a very easy website, safe.com. I paid $50 for that in '93. It could have had anything, but anyway, safe.com. And we have a whole webinar series that we do there that you're welcome to join, and we try to be informative in that and through that, and pick the topics you're interested in. We are going to be doing more than 70 world tour stops around the world. So if you go to our website and look for world tour, come next April and May, we'll be doing that. And we're having our every 3-year international gathering where all the data geeks of the world will gather here in Vancouver. So those are a few things. I would also say follow us on Twitter and Instagram at Safe Software. I'm at Dale at Safe. Don is at Don at Safe. And you can kind of follow along there to see what we're up to and what things are piquing our interest.
Again, Dale, this has been fascinating and I've really enjoyed it. Thanks so much.
Okay, all the best.
Thanks again to our sponsor, Hive Mapper. That's Hive as in Beehive Mapper. This is the company and this is the platform that takes airborne videos and turns them into a single living 3D map. And there's a whole bunch of amazing geospatial analytics baked into their system that you can use. It makes it really easy and user-friendly to get around. So if you're doing something with drones, if you're doing something with aerial mapping, if you're taking video data, collecting it from airborne platforms, I would highly recommend that you check out Hive Mapper. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I want to say a big thanks to everyone that's tuned in again this week. It's a real pleasure making these episodes for you, and I really hope you're enjoying them. If you have any feedback whatsoever, you are more than welcome to reach out to me on social media. You can find me at Mapscaping on Twitter, Facebook, and map_view on Instagram. I would love to hear from you. I just have one small favor to ask before I say goodbye, and that is if you have a friend or know someone who you think might enjoy this podcast, please share it with them. I would really appreciate it. Okay, that's it from me. Thanks again. We'll talk again next week. Bye.